This video is about the binomial distribution, and I want to show that the expected value is n times p, where p is the probability of success, and that the variance of the random variable x is n times p times 1 minus p. And so here we have the random variable x has a binomial distribution with the following probability density function: f of x equal to n factorial dividing by k factorial times n minus k factorial times the probability of success p to the x, and then times 1 minus p to the n minus x. And x takes on the values of 0, 1, 2, 3 all the way up to n. So now I'm going to show that the expected value of the random variable x is going to be n times p. And recall that the binomial expansion for a plus b to the n is this sum right here from 0 to n. And so we have the sum from 0, k runs from 0 to n. Then here b will be p, and a will be 1 minus p. And therefore this sum is going to be a plus b to the n. And so here we have 1 minus p plus p, which is 1. 1 to the n is 1, and therefore this sum right here is equal to 1. And similarly, a plus b, instead of n, if we have n minus 1, then there will be this sum right here. And therefore I have the sum that runs from k runs from 0 to n minus 1 with this expression right here. And then in b will be p, and then a will be 1 minus p. And so this is going to equal to a plus b to the n minus 1, but this 1 minus p plus p is 1. So 1 to the n minus 1 is still 1. And we'll need one more result: a plus b to the n minus 2. Then the binomial expansion is going to be this sum right here. And so I have the sum that runs where k runs from 0 to n minus 2 with this expression right here. B again will be p, a will be 1 minus p. And so we have 1 minus p plus p to the n minus 2, and this is equal to 1. And so the expected value is going to be the sum with x running from 0 to n with the expression x times f of x. This is f of x, the PDF. I'm going to write out the first term here. So when x is 0, then we get 0, n minus 0, p to the 0, and then here we get n minus 0. And then plus the sum with x starting at 1. We can see that this is 0. So the expected value of the random variable x is going to be this sum with x starting at 1. Now let's see bx minus 1. When x is 1, c is 0. When x is n, c will be n minus 1. N factorial is the same as n times n minus 1 factorial. X minus 1 is c. And then in the place of x here, we have c minus 1. And then once again here, x is c plus 1. And then x, here we get c plus 1, but here's minus x, so we get minus c minus 1. P to the c plus 1 is the same as p to the c times p to the first. And then we can move p to the first to the front of the summation sign right here. And then I'm going to move this n also to the front. So what's left will be n minus 1 factorial and then p to the c. A few moments ago, we have these three results right here. And so right here, instead of k, we have c. And so this sum right here is 1. So we have np times 1, which is n times p. And therefore, if for the random variable x, the expected value is going to be n times p. And now I'm going to show that the variance of x is n times p times 1 minus p. So first, let's find the expected value of the expression x times x minus 1, which is the sum from with x running from 0 to n with the expression x times x minus 1 times f of x. And since we have a binomial distribution here, then this is f of x. And then here I'm writing out the first two terms. When x is 0, then we're going to get 0 here, we get negative 1 here. And then when x is 1, we get 1 here, and we get 0. And then the rest of the terms is going to be the sum with x starting at 2. And we can see here that this term here will be 0, and this term here will be 0. And therefore, the expected value of the expression x times x minus 1 is going to be this sum right here, with x starting at 2. And now I'm going to let c be x minus 2. When x is 2, c it is 0. And then when x is n, c will be n minus 2. And here we get c plus 2, and then x minus 1 will be c plus 1. And then replacing each x here with c plus 2. And notice that c plus 2 factorial is going to be c plus 2 times c plus 1 times c factorial. And so the c plus 2 here is going to get cancelled out, and then the c plus 1 will also get cancelled out. And then what's left is just the c factorial. And then the n factorial, which is n times n minus 1 minus 2n minus 2 factorial. And then the p to the c plus 2, I rewrote it as p to the c times p to the second. And this summation here is with respect to c, so we can move the n, the factor n and the factor n minus 1 to the front of the summation sign. And then I also move the p to the second to the front. And so what's left is this sum right here. At the beginning of the video, we have these three results right here. And now we're going to use this last one right here. So here, instead of K, we have C. And so this sum right here, this is 1. So the answer is, and so the result here is going to be n times n minus 1 times p squared times 1. And so the expected value of x times x minus 1, x times x minus 1 is going to be x squared minus x. So we'll get expected value of x squared minus expected value of x. And then moving the term expected value of x to the left, we'll get expected value of x squared is equal to this. And so expected value of x times x minus 1 is going to be n times n minus 1 times p squared. And then a few moments ago, we saw that expected value of x is np. And so the variance of x is equal to the expected value of x squared minus expected value of x squared. And this expected value of x squared is going to be n squared times p squared minus np squared plus np. And then expected value of x is np, and then we squared it. And then here we have n squared p squared minus n squared p squared. So what's left is going to be negative np squared plus np, which is np times 1 minus p. And this is the variance of x, of the random variable x that has a binomial distribution. And that's the end of the video.